Okay, this here is test 2 review. And the tests are very closely related to the reviews, so it's really smart to look at all these videos. It's almost like a review session that I would give in a classroom. But you're lucky, you get to see all the problems. It takes too long to look at them all in a classroom, but you can take your time. Alright, we're going to start with questions 1 through 4. And these are making fractions from these illustrations. And this is important. Write fractions to represent the shaded and unshaded portions of the figure. So we're going to make fractions that represent the shaded portions of this figure and the unshaded portion. So it'll be 2 fractions. Alright, so we'll go to here. And this is question 1. I transferred it over to this format. So what we're going to look at is whether you're making a fraction for the shaded one or the unshaded portions, you're going to have the same denominator for these fractions. The denominator will always represent the total number of pieces in one whole. So the total number of pieces in this whole is 1, 2, 3, 4, 5, 6. 6 pieces total. The whole is cut into 6 pieces. Of those 6 pieces cut, 1, 2, 3, 4, 5 are shaded. And 1 is unshaded. So these are the 2 fractions that represent this picture. Now, both of these fractions are proper fractions, and proper fractions are less than 1. Because these pieces, if there's 5 of them, that's less than the whole of 6. And if you're looking at just this one piece, that's less than the whole circle, the whole pie, or the whole cut into 6 pieces. Alright, now for 2 wholes that are shown here, you still have the same denominator. But what you do is you look at how many pieces in one of the wholes. The wholes are both cut into the same number of pieces. So that's your denominator. But you only count on one of the wholes. 1, 2, 3, 4. Your denominator is 4 because the denominator tells you how many pieces the whole is cut into. Just because you have 2 wholes cut into 4 pieces doesn't mean you put 8. If you were to put 8 as your denominator, let's just complete this. This is what you're saying. If you put an 8 as a denominator, you're telling a person that the illustration is cut into 8 pieces and not 4. So the denominator always tells the person how many pieces one whole is cut into. Okay. The shaded portion, however, is going to be larger than one whole, and that's okay. You just count the pieces as if these were 2 pizzas sitting on a tray, and one pizza hasn't been eaten yet, and the other, a whole bunch has been eaten. 3 of these large pieces have already been eaten. So what you have left is 5 pieces. So the 5 goes there for the shaded. That's the pieces left. Then for the unshaded, what was eaten was 3 big pieces. This is larger than the denominator, so we can already assume, or you should be able to try to see in this fraction, that there's a whole cut into 4 pieces. Because remember, this is division. 4 into 5. 5 is the dividend, so 4 into 5. And if you think of it this way, does 4 go into 5? Yes, it goes 1 time. 1 times 4 is 4. 1. So you have 1 piece left over. And you use the divisor, it goes into the fraction. So you have 1 and 1/4. 1 and 1/4. Okay. So the next portion down here, you decide what is your denominator for the fractions. count the pieces in one of the holes. 1, 2, 3, 4, 5, 6. That's the denominator. You count your shaded portions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. Only one piece here has been removed. So that's the unshaded portion. 1. 1/6, this little teeny chip, which is less than 1, has been taken out. 11 pieces that are the size of 1/6 are left behind. Once again, if this fraction, since this number is larger, you're looking at it as 6 divided into 11. It can only go one time with 5 pieces left over. 11 minus 6, just like this is 5 minus 4. 1 and 5/6. So that 11/6 represents one whole plus the 5 pieces. Okay, so this last one here is back to a simpler one, just like this one. We make a denominator by counting the pieces in the hole. 1, 2, 3, 4, 5, 6, 7, 8. And we count the shaded pieces. 1, 2, 3, 4, 5. Count the unshaded pieces. 1, 2, 3. And you have the two fractions representing the shaded and unshaded portions. Okay, that's 1 through 4.